Hello friends, welcome back. Hearty welcome to you. Let us look at this problem. We have to find out the integral of 0 to pi by 2 sine cube x dx, and we have to prove that is equals to 2 by 3. Now we can solve this in two ways, at least two ways. One, what we can do, we can take cos x equals to t. That is the first method. In the second method, we can write sine cube x as 3 sine x minus sine 3x by 4. There are two methods in which you can do that. We will do it in the first method. So we will take down cos x equals to t. So I'll write down let cos x equals to t, then minus sine x dx equals to dt. Now let's change the boundaries. X equals to 0, that means t equals to 1. X equals to pi by 2, that means t equals to cos pi by 2, which is 0. So this became now 1 to 0, 1 to 0. Sine cube x, we can write it as sine x into sine square x. We'll write down one more step, sine x into sine square x dx. So maybe we will not change the boundaries because still it is in x only. We'll take it as 0 to pi by 2. Now next time we'll change this as 0 to pi by 2 minus of minus sin x dx, that will take care of dt, into sine square x. We'll write it as 1 minus cos square x. So this will become, now we can change the boundaries. X is 0, t is 1, and x is pi by 2, t is 0, minus of minus sin x dx is our dt. 1 minus cos square x is 1 minus t square. Now, can we write it as 1 to 0 t square minus 1 dt? Let's do the integral of this. We will get t cube by 3 minus t with the boundaries 0 to 1. That will give us 0 minus 0 minus of 1 by 3 minus 1, which is equals to minus of minus 2 by 3, that's equals to 2 by 3. So let's have a recap of this problem. We have been asked to find out the integral of sine cube x 0 to pi by 2 boundaries. Prove that is equals to 2 by 3. We took cos x equals to t, then minus sin x dx will become dt. Sine cube x can be written as sin x into sine square x. So minus sin x dx will become dt, and 1 minus cos square x will become 1 minus t square. Now let's look at the second method. How can we do that? Same problem in another method. Let me erase this. Let's write down integral of 0 to pi by 2 sine cube x dx. Now we'll use the formula that sine cube x is 3 sin x minus sin 3x divided by 4. Now that formula we will be using. So let us separate them now. One will be 3 by 4. 3 by 4 integral of 0 to pi by 2 sin x minus 1 by 4 integral of 0 to pi by 2 sin 3x dx. In the next step, we will write down 3 by 4 into sin x integral is minus cos x. So cos x with boundaries pi by 2 and 0 minus 1 by 4 integral of sin 3x is minus cos 3x by 3. So 1 by 3 cos 3x, boundaries are pi by 2 to 0. Let us simplify that. This will be minus 3 by 4 into cos 90 0 minus cos 0 is 1 plus 1 by 12 into cos 3 pi by 2, that is 0 minus cos 0 is 1. So it will become 3 by 4 minus 1 by 12. Now we can multiply with 3 and 3. Then it will become 9 by 12 minus 1 by 12, which is equals to 8 by 12, and that's equals to 2 by 3. So we can do this in two methods. In the second method, what we did? We have written sin cube x as 3 sin x minus sin 3x by 4. Then we integrated it. We know integral of sin x is minus cos x and integral of sin 3x is minus cos 3x by 3. We just did that and we applied the boundaries pi by 2 and 0. We know cos pi by 2 is 0 and cos 0 is 1. Simplifying, we will get 2 by 3. So that's how we can solve this problem in two methods.